Welcome to this series of operations management. Today we are going to discuss a new topic called process design and strategy. We have been talking about location planning, we have been talking about layout planning. In our last series we had discussed about various types of layout designs, product layout, process layout, fixed position layout, hybrid layout, group technology layout. Now today we are going to talk what are the various types of processes are there in the manufacturing system, in the services system, what kind of overall business processes are there and how do we design them. And basically when we design them there is a strategy behind it depending on the types of business, depending on the type of product which you are manufacturing over there. So it's a very important concept which we are going to study today. So what is process design? Process is various processes. A product, if it's a manufacturing company, it goes through several processes. The way it goes through several processes is called process design. Sometimes you enter the raw material in a system and then after a series of processes, after a series of manufacturing systems, finally you get the finished product. So it is one type of process design. Secondly, there is another kind of process design that there is no fixed route for the product. Sometimes you get a order for a product wherein you have to take various routes. There is no predetermined routes. So we are going to study all those things. What are the various kinds of routes which a product takes if you are manufacturing? Similarly, if it is a service industry, what kind of different departments it has to undergo before giving the final product or final services to your client. So process design is very important operational decision that affects the cost of operations, customer service and sustainability. So all your operations decision, the decision regarding your layout, whether it should be a product layout, whether it should be a process layout, depends on your process design, and your costing of your operations also depend on it. What kind of customer service you want to give, or that also depends on it. So therefore process design decisions, basically before studying that we should know what are the types of goods and services. So number one, custom or make to order goods or services are generally produced and delivered as one of a kind or in small quantities and are designed to meet specific customer specifications. Examples include ships, weddings, certain jewelry, estate plans, building and surgery. So these are kind of customized orders, whether it is manufacturing order or whether some service is customized. Because suppose you are going to a tailor to get a suit stitched. So it's a customized thing. You will give your own measurement. You will give instruction to the tailor that what kind of specifications you want, how many pockets you want, what kind of collars you want. You want a big collar, you want a small collar, you want tight fitting, you want loose fitting. So it is a one of a kind thing. So these are called customized products or make to order products. Similarly, you give order for a particular jewelry, so you give your own design. So again it is customized. A surgery, it may be the same surgery. Let's say it is a knee replacement surgery, but it will vary from patient to patient. Every patient is different. So the doctor will customize the surgery. The process has to be customized according to the patient's age, patient's internal conditions. So our processes will have to be designed according to these kind of products. So these are customized or make to order products. Second type of products, we would say option or assemble to order goods and services. They are configurations of standard parts, sub-assemblies or services that can be selected by customers from a limited set. Examples: Dell computers, Subway sandwiches, machine tools, travel agent services, automobiles, assembly lines. So these are called assemble to order products. So what kind of layout we would require? We would require assembly lines processes, which we are going to study. So there are some standard parts, these are assembled together. And then a package is given to the customer. For example, in our slide it was written earlier, it was travel agent services. Suppose you want to first go to Jaipur and then you want to go to Jaisalmer, then you want to go to Udaipur. So the travel agent will decide your tour accordingly. So it is customized for you, but it is a kind of assembling. So there are various tours. So he has a set travel route, but he is trying to adjust your travel route according to your requirements. So this is called assemble to order. Third kind of products we would say are standard products. Standard or make to stock goods and services are made according to a fixed design, and the customer has no options from which to choose. Examples are appliances, shoes, sporting goods, credit cards, online web-based courses, bus services, to name a few. So these are standard products. So standard products, you buy food products, you buy chips, you buy biscuits, you buy so many other things, standard things, you buy refrigerators, you buy TV sets. So these are standard goods which are made as per the standards which the manufacturers have set according to the customer's requirements. So these are called make to stock. So the manufacturer doesn't have to wait for the order from the customer. The manufacturer is making the goods for stocking, and then he sends the good to the various distributor and then to the dealers. So these are called standard or make to stock. So we will be studying what kind of process design is required for such kind of products. So let us now understand what are the various processes, or in other words we can also call them operations or production manufacturing processes. What are these various kind of processes? We are going to study them. So various kinds of manufacturing processes are: number one, continuous process or continuous production process, or we can also call them mass production process. Then comes batch production processes. Then third one is assembly line production process. Fourth one is job shop production process. And the last one is the project production processes. So we will be studying them one by one. What is continuous process, batch process, assembly line process, job shop process, and project processes. So number one, what is a continuous flow technology? So this is a process technology which is suitable for producing a continuous flow of products. So as the name indicates, continuous flow processes are those kind of manufacturing processes or those kind of industries or those kind of service industries wherein there is a continuous flow of products. So generally these kind of industries will be running 24/7. They will not stop the production. For example, if you see a fertilizer industry, if you see any chemical industry, if you see petroleum industry, if you take the example of paper industry, sugar industry, textile industry, so these are all continuous process industries, because continuously the industry, the raw material is fed from one end, and there are dozens of processes, sometimes hundreds of processes through which this raw material undergoes. There are some additions in between, there are so many processes, semi-finished goods, and finally you get the final product. And many times these industries are based on boiler systems, so turbine systems are there, steam flow system is there, so you can't stop these industries in between, because if you stop, the steam production will have to stop. So a continuous flow process creates highly standardized goods or services, usually around the clock, in very high volumes. So one of the characteristics is that they run around the clock and you get the products in very high volumes. Further characteristics, if we see, very high volumes in a fixed processing sequence, high investment in system, 24-hour, 7 days continuous operations, automated, dedicated to a small range of goods and services. Examples, chemicals, gasoline, paint, toy, steel factories, electronic funds transfer, credit card authorizations, paper, sugar mills, fertilizer plants. So, you can't make any other thing in a fertilizer plant. You can make different varieties of fertilizers, that is another thing. You cannot make any other thing in paper industry. You can make some 3 or 4 variety of papers over there. Similarly, in sugar mills, you can only make sugar. You can make some different varieties of sugar. You can make some brown sugar, you can say make crystal sugar crystals, you can make fine sugar, you can make coarse sugar, but you have to make sugar into it. So that is why we say, so the number of products, the variety of products is very small, but the volume of products which you make is very, very high. So that is the characteristic of a continuous process industry. So continuous process industry is also known as mass production system. So continuous production is resorted to when similar products are to be made and the volumes are large enough to demand a separate line for each product. So in this method, specialized machines are used to turn out similar types of products. So this is a very important characteristic, that you need specialized machines. In paper industry, the machines of paper industry are very specialized. In sugar industry, the sugar plant, the machinery are specifically designed for making sugar. In a fertilizer industry, similarly. In a milk industry also, it's a continuous process industry. Generally, food industry is also a continuous process industry. So you have the systems, you have the vessels over there, you have the machinery which has been designed specifically to make that particular product. So another feature of continuous production is continuous production employs a product layout. So we have studied what is product layout, because product layout is designed for a particular product. So in this system, machines are arranged in the sequence of production flow system, which we have studied earlier. What are the merits of continuous systems? So number one, merits of continuous systems are, number one, material handling is easier since the flow is predetermined and regular. Production planning and control, PPC, is simpler. Production time is fixed and predetermined. WIP, that is work in process materials, are generally small and hence does not involve large capital and space for such inventories. Skills of moderate order are necessary as the work is monotonous. So because there is a set route, there is a set sequence, it's a product layout, so not much material handling is required, unlike a process layout. Production planning and control is simpler because there is a fixed schedule. You are making the similar kind of products day in and day out. So therefore your production timings, your shifts are fixed. So generally such industries are run in 3 shifts of 8 hours each. So everything is predetermined. And in between, semi-finished goods, work in process materials are not so much as in a process layout. And skills of moderate order, because a supervisor or a worker is working on the same machine and he or she has to do the same job every day. So person becomes skilled over a period of time. But let us see what are the demerits of continuous systems. Because in management we have to see both sides, merits and demerits. So demerits are more machines and duplication of machines are required, more capital intensive industries, high investment in machines and infrastructure, no flexibility with respect to personnel and equipment, may sometimes lead to low job satisfaction for the operatives or for the workers. So demerits are because you people have studied the layouts. In product layout also you have studied that in a product layout more machines are required. If there is a drilling machine at one point and you need drilling machine at various other points, so you have to install various drilling machines. The material will not travel to a drilling department. So whatever machine is required, it has to be placed in the sequence of the flow of the material. So therefore duplications of machines are required, so that more capital is required. So, and mostly such industries are more capital intensive industries, right? So because a person is working the same job as we have just discussed, so sometimes we may say that there is low job satisfaction. Some people want to do a variety of work, but it's the same work for the people who are in the production line. At some point of time, they may feel boredom. Let us understand the second kind of technology or second kind of process design, which is known as batch production systems or batch technology. A process technology suitable for a variety of products made in different batches in varying volumes. So what is a batch production system? Here you don't make one product, you make a number of products at one point of time. For example, I gave you the example of a tailor. A tailor customize the garment for the customer. The customer gives the cloth and the tailor takes the measurement and makes. But that tailor is making only one garment for the customer. Whereas if you see a garment industry produces shirts, let's say. So they are producing a lot of shirts of various sizes. Let's say we see the adult size. So this garment industry is making shirts of 38 size, 40 size, 42 size, 44 size. So they are making in batches, they are making in bulk, and they have to make different colors of those shirts, different sizes of those shirts. Sometimes, but they are not continuously making the same kind of shirts. Next time they will make shirts of a different cloth, different design, different color codes. Let's say today they are making a batch of a plain shirts, tomorrow they will make a batch of a check shirt, then third time they are making the shirts of linings, and so on and so forth. So that is an apt example for a batch, a garment industry. Similarly, there are many other industries who make products in batches. They get order in bulk and they make products in batches, that is in high volumes. Again, next time they may get a different kind of products. So that is called batch production system. So what is a batch production? It is resorted to when a variety of products are to be made and the volumes are not large enough to demand a separate line for each product. In this method, general machines are used to turn out different products. What are the features of batch production? Batch production employs a process layout. In this system, similar machines are grouped into a department. So the volumes are moderate, not very high, not very small. So they are not making one piece, they are making pieces in batches. Next time a new order comes, so they may have to adjust the machines accordingly. So therefore you need process layout. So process layout is the layout where the machines are grouped as per their characteristic. For example, in a garment industry, there is a sewing department, there is another department for stitching, there is another department for buttoning, there is another department for cutting, there is another department for designing, etc. So therefore, whatever order this company gets, the product will flow in a jumbled flow. There is no set route for the product. So what are the merits of batch systems? Here merits are fewer machines are required, specialized supervision is possible, not so capital intensive, low investment in machines, flexibility with respect to personnel and equipment, job satisfaction for the operatives due to different variety of work done. So what was the demerits of a continuous process systems becomes the merit of a batch production system. So in continuous production systems, we had seen that more machines are required, it's more capital intensive, whereas batch production systems, fewer machines are required because process layout is used. And it's not as much as capital intensive as continuous process industry is there. And there is a lot of flexibility to people and equipment. Sometimes you may not require a equipment, particular department or particular machine to produce a particular product, whereas in a continuous process layout, it's all predetermined. Every machine is required because there is a fixed sequence to make that material. And there will be more job satisfaction for the people who are working over there, those who want variety, because variety of work is required, so variety of challenge is there. What are the demerits of batch systems? Demerits are material handling is costlier since the flow is longer and irregular. Production planning and control, PPC, is elaborate. Production time is generally longer. WIP, work in process materials, ties up large capital and space. Skills of a higher order are necessary considering the variety. So, whatever were the merits of continuous process systems becomes the demerits of a batch system. So, here, because every product is different, every product passes through different routes, so therefore material handling is more. So, you have to spend more money on handling of the materials. Production planning control is also more complex because every time you have a new batch, so you have to plan your production accordingly. There is no set product which you are manufacturing round the year. So, sometimes a batch may take 15 days to make, sometimes a batch may take 2 months to make, but you have to change according to the next order. So, therefore, and skills of higher order are required because every time there is a new order, new designing, you have to design it again, you have to plan your production accordingly. So, you have to require higher skills for your workers. Let us now see which is the third type of process design. It is known as assembly line technology or assembly line production systems. It's a process technology suitable for a narrow range of standardized products in high volume. Many times, some books also say that continuous process industry and assembly line are similar. The difference between a continuous process industry and assembly line industry is that a continuous process industry generally works 24/7. An assembly line technology may work 24/7, may not work 24/7. For example, the most appropriate example for assembly line technology is automobiles, whether it's making a four-wheeler or whether it is making a two-wheeler. If you see any industry which is making two-wheelers, it may be Bajaj Auto, it may be Hero Motocorp, it may be TVS, or it may be a four-wheeler industry, a car industry, Hyundai, Maruti. So, they all are running on assembly line technology. For example, when you buy a particular model of a car, in that particular model also there are various variants of that. Let's say, if you take the example of Maruti, they make LX, they make LXI, they make VX, they make VXI, so that there are various versions. So, there is some commonality in the basic car, but afterwards, some additions are there. So, it will follow a particular line. So that will be common. After that, some variants are there. In some model there are 2 airbags, in some model there are 4 airbags. So there will be a change after that. So that is called assembly line technology. And many times the engine of 2 or 3 models are the same. So engine is made at some place and then finally it is assembled on this assembly line for this particular model. So such kind of technology is known as assembly line technology. So it is applicable for automobiles industry, it is applicable for consumer durables like TV industry, like refrigerators or other white goods. We will be talking about it more in the second version. Thank you.